Hello, this is Mr. Waters, and I'm going to do some examples from today's homework on page, or rather, today's homework, page 632. And they'll all have to do with writing the equation of a parabola and then graphing it. And we'll be starting out with some information in order to be able to do that, but in each case we'll start out with different kinds of information. Here's one. Let's say we're given this information. We're given that the vertex is at 0, 2, V for vertex, and we're going to be given that the focus, F for focus, is going to be at 0, negative 3. Now, in order to kind of get an idea of how that's going to go together and help us make the equation, we'll start out by drawing a little graph, and I'll do that over here. Kind of messy, I know, but hopefully this will be clear enough. Okay, so there it is. Now I'm going to graph 0, 2. So 0, 2, that's right about there, and that's going to be our vertex. And the focus is at 0, negative 3. That's down about right there. That's going to be our focus. Now, the problem doesn't directly ask for it, but it's a good idea to know where the directrix is, because that'll help us visualize where the parabola will be and to be able to see how the equation goes together. Now, the directrix is at the same distance above the vertex in this parabola as the focal point is below. The focus is 1, 2, 3, 4, 5 units below, so the directrix is going to be 1, 2, 3, 4, 5 units above. Now I'll go ahead and sketch that in, and you can see here that the graph of that is going to be, or the equation of that is going to be y equals to 7. Okay? Now, what we also get from that is that the distance from the focal point to the vertex point is 5. So the focal distance, the c, is going to be equal to 5. So that's going to help us write the equation too. All right? We can see that the parabola is going to be vertically oriented because the directrix is horizontal, and since the focus is below, in order to make the vertex, the parabola, go through the vertex and curl around the focal point, we have to have it opening down. So we're going to have a vertical parabola here opening down. Now the formula for a vertical parabola is y minus k is equal to a times x minus h, quantity squared. And the h and the k is the vertex, and so back up here, that's the h and that's the k. So we write here, right off, we got y minus 2 is equal to a times x minus 0, quantity squared. Now all we have to do now is solve for the a value. Well, in order to get the a value, we're going to use our handy-dandy value because we know the focal distance c. So c will, or rather a, will be equal to 1 over 4 times 5, which is equal to 1 over 20. Now also, since our parabola is opening down, that focal distance 5 technically is really negative, so that's going to be negative 1/20. So when we write our equation, we'll have y minus 2 is equal to negative 1 over 20 times x minus 0, quantity squared. Now simplifying all that, adding 2 to both sides, y is equal to negative 1/20 x squared plus 2. And there we're done at least writing the equation. Now to graph it, we're going to go ahead and find a couple of points. And a couple of convenient points, and we'll record this in a t-table. There's the x and there's the y. Well, you can see here that in order to make a t-table, we're going to pick a couple of convenient points around the vertex and then reflect them using symmetry to find 2 other points to the other side. So since we've got x equals 0 for the vertex point, I'm going to use x equals 1 and x equals 2. So 1 and then 2. So I'll put 1 in where the x is. So this is y is equal to negative 1/20 times 1 squared plus 2. Well, 1 squared is 1 times negative 1/20 is negative 1/20 plus 2 is equal to 19 over 20. So 1 comma 19 over 20 has to be on our graph. Okay? So that's one of the points. And now we put 2 in to get the second point. Negative 1/20 times 2 squared is equal to negative 1/20 times 4 plus 2. 4 over 20 is 1/5. So it's going to be negative 1/5 plus 2, which is 1 4/5. So the point 2, comma, 1 4/5 is on our graph as well. So we go ahead and put those on up here. And what am I saying? Okay, so let's see. So over 1 up 19 over 20, that's just below the 2, so it's about right there. And then over 2 up 1 4/5 is just a little bit further down, about right there. Symmetry allows us to reflect this over and get a couple of points there and get a couple of points there. Draw our parabola smoothly through, and we're done. So we can see that that very neatly works out to have the parabola opening down. So here is our graph, and here is our equation. Thank you. Stay tuned for example B.